Hello and welcome. Today, we're going to pull back the curtain on some incredible hidden technology. It's working behind the scenes, to make sure that so many of the foods we eat every single day are pure and top quality.
So, have you ever really thought about how your glass of milk is so perfectly creamy, so clean? Well, let me tell you, it's not some kind of magic. It's actually a super powerful industrial process called mechanical separation. And this, my friends, is the science that takes raw materials and transforms them into the safe, consistent products we see on our supermarket shelves. All right, so here's what we're going to cover. First, we'll get into the whole idea of the purity process itself. Then, we'll see how we clear up air and water. After that, we'll dive into the science of spin. It's fascinating stuff. We'll also look at the machines, the real workhorses of the dairy industry. And finally, we'll connect all the dots and understand why this separation business matters so much.
So, first things first, separation is at its core one of the most fundamental operations in all of food processing. I mean, it's the unsung hero, really. This is what guarantees safety, makes sure the quality is just right, and believe it or not, it even helps in creating brand new products.
So what is mechanical separation, really? Well, it's basically a bunch of physical processes. Things like sieving, filtration, centrifugal separation. The main goal is simple: to separate different components from a mixture. In the dairy world, for example, this means separating fat from milk to make cream, or removing any unwanted stuff from raw milk. It can even mean filtering fine powder from the air in a dryer. It's all about physically sorting things out. Think of it like a super advanced sorting system for things we can't even see, like those tiny impurities floating around in your milk.
Okay, so how does this all actually work in practice? Let's get into it. We'll start by looking at two of the most common ways we separate tiny particles from fluids in the industry.
Let's start with filtration. The easiest way to picture this is to think of a really advanced coffee filter. You've got a fluid with some particles suspended in it, and you pass it through a porous medium. This medium, it traps all the solids, and what you get on the other side is a clarified liquid, which we call the filtrate. And this process is used for so many things, from cleaning up raw milk to making cheese.
But what about separating something really fine, like dust, from the air? Filtration has its limits, especially when you're trying to pull microscopic dust particles out of the air, say in a drying plant. For that, you need something much cleverer. You need a controlled, miniature vortex.
And that brings us to the cyclone separator. It's such a cool device. Here's how it works. First, the gas, full of dust, enters from the side at a really high speed. Because of inertia, the heavier dust particles get thrown against the outer wall. From there, they just slide down the conical wall and into a collector at the bottom. And the clean gas, it spirals up and exits right through the middle. What's so amazing here is that it's using pure physics, inertia, not a filter, to clean the air. It's literally like a high-speed merry-go-round for dust. Okay, so we've talked about filters and vortexes, but now let's get into the real heavy hitter, the science of spin. You see, sometimes just waiting for things to settle down using gravity is way too slow, especially when the particles are super tiny. So, what do? We amplify gravity's effect thousands of times over, all by using the incredible power of rotation.
And get this, in some of this equipment, the centrifugal force can be 2,500 times stronger than gravity. Can you imagine that? This incredible force is the absolute key to separating things that have only very small differences in their density, like, for example, those tiny fat globules floating around in milk.
So why does this spinning work so well on milk? Well, this table shows it perfectly. Look at the specific gravity, or density. Fat is at 0.93, while skim milk is at 1.036. So the fat is lighter, right? It's less dense. When you spin the milk at these crazy high speeds, the heavier skim milk gets thrown outwards, while the lighter fat, or cream, gets pushed inwards towards the center. It's such a simple principle, but man, is it effective.
Now, the actual physics behind this is all described by something called Stokes' law. In simple terms, this law tells you how fast a particle will rise or sink in a fluid. It depends on its size, the density difference, and how viscous the fluid is. But here's the kicker. Centrifugal force dramatically, and I mean dramatically, speeds this whole process up. So you can think of Stokes' law as the rule book for separation, and the centrifuge, that's the machine that takes the rule book and just puts it on fast forward, turning a process that could take hours into just a matter of seconds.
All right, so we've covered the physics. Now let's meet the actual machines, the real workhorses that apply these powerful principles every single day in dairies all over the world.
So in the dairy, you'll mainly see two types of these machines, clarifiers and cream separators. Now, they might look similar, but their jobs are totally different. A clarifier's goal is to remove solid impurities from a liquid, like getting dust out of milk. It has one inlet for the milk, one outlet for the clarified milk, and all the sludge just collects inside. A cream separator, on the other hand, is designed to separate one liquid from another, like cream from milk. So it has one inlet but two separate outlets, one for the cream and one for the skim milk. So one is for cleaning, the other is for separating.
Let's take a look inside a hermetic cream separator. This is where the real engineering magic happens. First, you have a hermetic seal. This means the whole system is airtight, so no air gets in to create foam. Then you have the disc stack. This is the heart of the machine. It's a stack of over 100 conical discs, and they're spaced just 0.5 millimeters apart. This creates a massive surface area for separation. The whole bowl spins at incredible speeds. We're talking 5,500 to 6,000 RPM. And finally, you have built-in pumps called centrifugal pumps that discharge the cream and skim milk under pressure. That disc stack is the real genius here. Because the discs are so close together, the fat globules only have to travel a tiny distance to be separated. It makes the whole process incredibly fast and efficient.
And the technology keeps getting better. Some of the more advanced centrifuges are called self-desludging. What does that mean? It means they can automatically eject all the collected sludge without even stopping. This is an absolute game changer for big dairies. You don't have to stop the entire production line just for cleaning. It allows for continuous, non-stop operation, which, as you can imagine, is a huge deal for efficiency.
So, okay, we've talked about all this high-speed spinning and filtering. But what's the bottom line? Why does any of this separation stuff actually matter to us, the people drinking the milk?
Well, for one, look at this number, 99%. There's a special process called bacto-fugation, which uses a special kind of centrifuge that can remove up to 99% of bacteria from milk. It literally spins the bacteria out. This isn't just about making the milk taste better. This is a massive, massive step forward for food safety.
So you see, the benefits are huge. We're talking about safety, first and foremost, removing contaminants, impurities, even bacteria. Then there's quality. It ensures we get that consistent texture and purity every single time. And it drives product innovation. It's what allows for the creation of cream, skim milk, clarified ghee, and standardized milk. And of course, there's efficiency. These high-speed continuous processes are absolutely essential for our modern food supply chain. It's not just about cleaning. This technology is the foundation of the entire dairy aisle.
So really think about this. The next time you pour yourself a glass of milk, you'll know about the incredible high-speed journey it took to get to you. That one single operation, separation, is what transforms a simple farm product into this huge variety of safe, consistent foods that we all rely on. It's a journey that's powered by some brilliant physics and truly remarkable engineering.
And that really makes you think, doesn't it? What other invisible technologies are hiding in your food? This is just one example of the incredible science that's always working behind the scenes to bring food to our tables. It just makes you wonder what other fascinating processes are hidden in plain sight, all working to make sure our food is safe, nutritious, and of course, delicious.